This conference will now be recorded.
Okay, so this is aceclofenac. See, you can see the structure is given, its molecular weight, the chemical formula, then how pure it is, the description that it is white or almost white crystalline powder. So whatever you can see under each drug, it's called as a monograph. So there we can see the chemical formula, the molecular weight, the description, identification, how you will identify. So different tests. And so if you have an unknown compound, of you know if this particular is a compound is aceclofenac, but you want to make sure it's the same drug, so then you can carry out these identification tests. So test A, B, C by various different way and techniques like IR here they have said. Then by using, then some chemical tests also there. Then again liquid chromatography test. Then uh, then that also the storage is mentioned, if you can see. Okay, the storage. Then below that, this is another. Beside, it's not only the pure drug, even the dosage form like aceclofenac tablets also they have given. So if you have a tablet in your hand and you want to confirm whether it is aceclofenac, so you will carry out the identification test according to one which is given in the pharmacopoeia. Okay, so like this, in each volume there are many monographs. So if you want, I can share even the same PDF soft copy, and you can see how a pharmacopoeia looks. And usually at the end there is appendices, but here this is volume 2, so there is one more volume 3. So here it is only up to M, letter M. So after the next letter M, O only it is. So M, whatever M, if there is letter N and all will up to Z will come in volume 3. Okay, and at the end will be the appendix. Okay, so that is how, this is how a pharmacopoeia looks. Like you all must have learned about the limit test. So those also mentioned on in this monograph or in this pharmacopoeia. Okay, so I'll stop sharing this and we will go to the next one. So that, yeah, next second topic is metrology. In the syllabus, what all you have to cover is the system of weights and measure, calculation, including conversion from one system to another system, the percentage calculations and adjustment of products, use of alligation method in calculations, and isotonic solutions. Okay, so why do we need to know about the various kinds of calculations? Because see, previously we had this term known as compounders. So what they used to do is they used to prepare then and there in the pharmacy, and they used to dispense it to the patients. So for example, right now allopathic or English medicine, it's already there. They just give you the ready-made dosage forms in the form of blisters or strip packs, or sometimes the tablets are also in the bottles, liquids or syrups in bottles. So these are already prepared and they just simply dispense it to you, right? But in homeopathic, Ayurvedic, so they in the pharmacy itself they are going to prepare it and then dispense it. And so in this prescriptions, they would give many terms like ounces and all, so which you usually hear in only in Ayurveda, and for and what is that, in homeopathic, it's normally they will say one pouch or one small sachet of powders will be given. Whereas in allopathic, it's usually they will mention how many tablets to be given. So that usually the number is mentioned there. So thrice a day or twice a day or once a day will be mentioned. So for these, so in the olden days, the pharmacists had to know how to, they should have good or very good knowledge regarding what all kinds of weights and measures are used. That so because of that only we have to study this particular topic. So basically, there are two types of weights and measures, or two systems of weights and measures. So imperial system, which is an old system, and the second one is the metric system, which we are currently using. Okay. So metrology is nothing but the study of the calculations, pharmaceutical calculations by various systems. So, under metrology, as I said, there are two systems of weights and measures. First is the and imperial system is an old system, no longer being practiced except for in Ayurveda and all. And but that's what, as I said, very old physicians would be still using that system. So that's why we still have to be familiar with it. The newer people, physicians will be usually using the metric system. Okay. So under the imperial system, again, we have something, see, how do you measure something? Usually in terms of weight and also in terms of volume, right? So if I want a rice, I will go to the shop and tell I want 10 kg of rice, right? That's the weight in kilograms or grams. Okay. And besides that, if you want something in form of liquid, in terms of volume, if you have to measure, or in terms of capacity, so you will tell in liters or ml, right? Like for you, for example, your packet of milk will be available in half a liter or 500 ml. So always remember there are two types. One is in terms of weight and the other will be in terms of capacity. So imperial system again is divided into two types. That is your avoidable system and the other one is apothecaries system. Is it clear so far? Should I again go back and explain to you all? I hope it's clear what is imperial system and why we have to study about these various weights, measures, and systems of weights and measures. Okay. So imperial system, the older system, is divided into two types, that is avoidopoise and apothecaries. Now, in how both are different is, in the first one, the pound, Pound, pound is a standard unit and it's given by or denoted by LB. Okay, so it should be capital L and small b. And so all the measures of mass are derived from the imperial standard pound. So pound is the main basis or the standard unit for weight. Whereas in apothecary system, it is a grain instead of pound. There here grain is the standard unit and all other weights are then derived from it. So that is the main difference between the two. Avoidopoise, your pound is a standard unit and all others are derived from that pound, and whereas in apothecaries it is grain, grain, grain. And apothecary system is also commonly known as the Troy system, TROY, Troy. Okay. So how do we convert? So first table, what you can see, that is 1 pound, that is the avoid poise system, and 1 pound is equal to 16 avoid, AVOIR. Okay, and 1 pound is also equal to 7,000 grains. So if I want to know how much is 1 avoid, I have to cross multiply. Okay, I simply have to cross multiply, and then what I will get is 7,000 divided by 16, which is equal to 437.5 grains. So remember, this first table is your avoid system, where pound is the standard unit for weighing and all others are derived from pound. So 1 pound is equal to 16 over and it is also equal to 7,000 grains. So therefore, if I want to know how much is 1 avoid, I have to simply take 7,000 grains divided by 16, which is equal to 437.5 grains. Okay, so next table, that is the apothecary system, which is also known as, can anybody tell what was the other name for apothecaries system?
Troy system.
Troy system. Okay, good. So in this, your standard unit was what? Unlike the avoid boys, it is grain, GRAIN, grain. So in the previous one, it is pound. In this, it is grain. This is your standard unit. So here, 20 grain is equal to 1 scruple and 60 grain is equal to 1 dram. So CH is silent here. It's pronounced as DRAM, dram. Okay. 480 grains is 1 ounce. So see, it's according to apothecary here. This is not that OZ ounce here. So this is the apothecary. But and 12 ounce is also equal to 1 pound, which is again apothecary, and 576 grains, which is equal to 1 pound. So these you all should by heart. Okay, so keep writing and then you will be able to memorize this. So usually they will ask the conversion from one factor to other. They may ask how many grains is equal to how many 4 ounces is how many grains they can ask. So you have to simply write 7,000 by 16 into 4. If you calculate, you will get how many grains it is. Okay, so memorize these tables, whatever is there in the in this chapter, the second chapter, metrology. Is it clear? Apothecary and avoid boys. Here 1 pound is 16 OZ or avoid. 1 pound is 7,000 grain here, and 1 OZ is equal to 7,000 by 16, which is equal to 437.5 grains. In the apothecary system, it is 20 grains is 1 scruple, 60 grains is 1 gram, and 480 grams is 1 ounce. 12 ounce is equal to 1 pound, and 5760 grains is equal to 1 pound. So whatever we studied so far is the measurement of weights in terms like of kg, how we see the same way in terms of weight in the imperial system. Excuse me. Next is the measurement of capacity. As I mentioned, if you want to measure something, in volume, in terms of volume. So nothing but measurement of capacity in imperial system. So how will you do? So this is the table given. So unlike the previous one for that is measurement of weights, where we saw we have two separate system or the separate standards. Here for both avoid and apothecary, the standard unit is same. It's 1 gallon. That is, gallon is the standard unit. In measurement of weights, in avoid you had pound, and apothecary you had grain. Whereas in measurement of capacity, it is gallon, which is common for both avoid and apothecary system. So from gallon, we will get the other measures of capacity. So 1 gallon or C denoted by C is equal to 160 fluid ounces. So you must have seen when you go to an Ayurvedic physician, he will write you should take 1 ounce of so much arishta. So that's how they measure. So 1 gallon is equal to 160 fluid ounces. Okay, this is fluid ounces. And 1/4 of gallon is 1 quart, QUART. 1/8 of a gallon is 1 pint. 1 by 1/60th of gallon is equal to 1 flounce. 1 by 8 of a fluid ounce is equal to 1 fluid dram. So that's not mentioned here. So see, these are the ones. So 1 quart is nothing but 40 fluid ounces. 1 pint is equal to 20 fluid ounces. 1 fluid ounce is equal to 480 minutes, and 1 fluid dram is equal to 60 minutes. So again, you have to memorize these measures. Okay, so till your 4 years, you will have to remember all these things. Simply keep writing and practice, and then you will be able to remember these measures. Okay. Moving on to the next slide. That is the metric system. So Till now what we studied was the imperial system, which is the old system and which is not being used now as such. Only very old physicians would be using these imperial system. So metric system is the one which is in use, and it's implemented in India since 1964, that is 1st April 1964, in the pharmacy profession. So again, similar to imperial system, even metric system also has measurement of weights and measurement of capacity. So coming to measurement of weight in metric system, what is the standard unit? As I said, it's kilogram. Kg is a standard unit, and you get all other measures from this. So from higher to lower. So 1 kg is equal to 1000 grams. Remember this. 1 hectogram is 100 grams. 1 deca means 10. So remember 10 grams. 1 deci is 0.1 grams. And 1 centigram is 0.01 grams. 1 milligram is equal to 0.001 grams. 1 microgram is equal to 0.12345 zeros and 1 gram. Okay, so these you all must be familiar. We have been using in school level in the 11th and 12th, all in physics and other calculations and all. 1 kg is how much. So this is very easy. You can easily memorize these, unlike the previous one. So next is the measurement of capacity. So whatever we studied previously was the measurement of weights. That is, kg was a standard unit. So under measurement of capacity, it is liter. Liter is a standard unit, and you will get all other capacities from this liter. So 1 liter is equal to 1000 ml. Everybody knows this. Okay. Next, moving on to the conversion tables. So see, in that Indian pharmacopoeia, we have only this metric system. They do not use imperial system. But as I mentioned previously, but the prescription in many is still written by many old-time physicians, not the new generation. A very old physicians, they would be still using 1 grain you should take, or 1 ounce of syrup you should take. So for that purpose, this conversion table is used by the pharmacist. So weight measures, so we are going to compare both metric and imperial system, and from metric you're going to convert to imperial system, same. So for weight measures, so 1 kg means how much pounds? It is 2.2 pound. Okay. 30 gram is equal to 1 ounce. 450 gram is equal to 1 pound. It is a wire. And 1 gram is equal to 15 grains. 60 mg is equal to 1 grain. So if I take 5 kg will be how many pounds? Please calculate and tell me. Are you all there? Whom am I asking this question?
I'm 11 pounds.
Any other answer? Everybody is getting the same?
11,
Yeah.
ma'am.
Correct. So 5 kg is equal to, you're supposed to multiply 2.2 into 5. Clear, no? So this is the way how you have to calculate. So from the metric system, you're converting into the imperial system, or if they have written in pound form, you can convert way back to kg system also. So this was the weight measures. Below table, what you can see is the capacity measures is in terms of volume. So here 1000 ml is 1 quart, 500 ml is 1 pint, 30 ml is 1 fluid ounce, 4 ml is 1 fluid gram, 1 ml is 15 minim, and 0.06 ml is 1 minim. Clear? The conversion table. So please memorize this table also. Next is the conversion table for domestic measures. So see, when at home you have to bake something and all, they will mention you have to take one or not only bake, anything you are going to make, they will tell you are supposed to take 1 teaspoon, 1 dessert spoon, 1 tablespoon. So how much is that equivalent to in the metric system and in the imperial system? So metric system, 1 drop means 0.06 ml, whereas in imperial system it's 1 minim. So that's easy to remember. 1 drop is 1 minim, both, and it is 0.6 ml. 1 teaspoonful is 4 ml. So teaspoon is naturally little larger or more than a drop. So that is 4 ml, and it is in imperial system it is 1 fluid dram. 1 dessert spoonful, so it is twice that of a teaspoon. So if teaspoon is 4 ml, 1 dessert spoon is 8 ml. And again, it is imperial system is 2 fluid grams. So see the correlation you can. So if you remember 1 teaspoonful, you can always write the dessert spoon, how much it is, because it's just twice. Next, 1 tablespoon is 15 ml. Okay, so it's almost twice, you can say, not exact. And in imperial system, it is 4 fluid dram. So 2 tablespoon will be naturally 15 into 2, that is 30. And in imperial system, it is dram is converted, it's become 1 fluid ounce. And a 1 wine glass spoon will be 60 ml. So see, that's how, and when they go to these restaurants and all, how they measure this liquor and all in terms of pint or a wine glass. So 1 glass full means it is 60 ml. Okay. So it is wine glass full is twice 2 tablespoonfuls. So there again you can correlate this calculations and memorize the values. And a tumbler full is 240 ml. That is 4 times a wine glass full. Same way in imperial system it is 8 fluid ounce. Okay. So next one, actually there is percentage calculations and all. So I thought I'll take it in the next class. We will go to the alligation method. So alligation method is something very easy for you all to understand. So this method is whenever you are taking or mixing two preparations. So similar preparation like alcohol. So both are the preparations. If I have A preparation and I have B preparation, both are same or similar. Alcohol only. A also is alcohol. B is also alcohol. But A will have a different strength. B will have a different strength. So when you have to mix both this, you're going to get something. A strength will be in the middle or intermediate. So if one is very strong and the other is weak, so when you mix both, it will be in the medium strength, right, or intermediate strength. So for that reason, how you're going to calculate it, for that purpose we're going to use this alligation method. So this method is usually used for checking the calculations. So here, as I said, when it mixing of two similar preparations of different strength, one could be strong, the other will be a weaker strength, and to produce a preparation of intermediate strength. So that time we are going to use the alligation method. Okay. So see, towards the left, here is the stronger percentage. Then you're supposed to write towards the right the weaker percentage. In the middle, you have to write required percentage and then mark the arrows. So stronger percentage you have if you want required percentage. So what you're going to write here, down arrow is your stronger minus your required percentage. Okay, so that will be your weaker percentage. Yes. In the same way, here down you're going to write the required percentage minus weaker percentage. So what you get is your, this side is your stronger percentage. So with the help of an example, it will be more clearer for you all. Okay. So So remember, for stronger percentage, here it is ulta, opposite. It's required percentage minus weaker percentage, and here it is stronger minus required. So now I want to calculate the volume of 95% alcohol required, which is required to prepare 600 ml of 70% alcohol. So in the previous, see this, what is in the middle, required percentage. Okay, so calculate the volume of 95% alcohol required to prepare 70% alcohol. So you have with you 95% alcohol in hand, remember, and from that you have to prepare the strength, that is 70% alcohol, and the volume is 600 ml. So whenever you get any calculation or any problem, always you should write first what is known, right? So that is volume required is what, how much you have to prepare, 600 ml. Percentage of alcohol required is 70%, and percentage of alcohol used is 95. So write those terms which are already known. Okay, and so here, if you go back to the formula in this pink box where you see the required percentage, you can see what is written, 70, because you have to make 70% alcohol. That is the required percentage of alcohol. Then the stronger percentage, now see here we don't have two different strengths, it's only one strength. Okay, so that is stronger naturally. 95% means the strongest percentage only. So your weaker is 0 here. So in case of stronger percentage, you have to write 95, and where weaker is there, you should write it as 0. Nothing is added. It's only you're preparing it from 95% alcohol. There are no two separate preparations are not there. Okay, so again, when you see that this, what was below towards the right side, it is written stronger percentage minus the required percentage. So that is here stronger minus required. So 95 minus 70, which is equal to 25. Okay. And again, if you go back, here what is there? This side towards the left, required percentage minus weaker percentage. So required minus weaker. So here nothing is there. So here they have written as 70 minus 0. It's considered as, there is no negative here. So it's considered as positive 70. Okay. Clear how they have got? So,
Yes, ma'am.
yeah. So 70. So how much you have got? If you see 70 parts of 95% alcohol, and whatever here 0 was there, it's supposed to be taken as, since you have no other alcohol, only one preparation alcohol from there, so you'll be adding water to it. So 25 parts of alcohol will produce the required percentage alcohol. So see, 70 is your alcohol, and this 25 what you got from 95 minus 70 is 25, that is water. Okay, which was here as 0. So 25 parts of water will produce the required percentage alcohol. So remember the left portion, that is 70 parts of alcohol, and the strength was 95% what we have in hand. And the remaining, you went to dilute that particular alcohol, you're going to add water. So how much water has to be added? We got 95 minus 70, 25 parts of water will produce the required percentage alcohol. So quantity of alcohol required is equal to, you have to multiply the volume required, which was 600 ml, into your percentage of alcohol, or your 70 parts of alcohol, what you got, 70 percentage divided by the 95 percentage of alcohol used. Okay. So 600 volume of This is 600 into the parts of alcohol, that is 70, divided by your strength, that is 95, which is equal to 422.10 ml. So what we know is only of how much alcohol is required. So naturally you cannot simply use it as it is 422. You have to add water to dilute it. So how much they had mentioned? 25 parts. So in terms of volume, what we will do is volume required was 600 ml multiplied by the 25 parts divided by the percentage, whatever volume is of alcohol, I'm sorry, not volumes, or the strength or the percentage of the alcohol which has to be used, that is 95. So you will get 157.9 ml. So when you add both, you can see if you want to simply check. So if you add both, you will get 600. So you can always stop till here. Quantity of 95% alcohol you can calculate. You will get 422.1, and you can simply subtract 422.1 from 600. So 600 minus 422.1 will give you 157.9 ml of water. Understood this particular example? Do you all have any doubt? Because I'll not go further. Stop at this particular calculation only. So I want, if you all have any, isn't it moving? Oh. Did you all understand this particular example? So when do you use alligation method? Remember, when there are two similar preparations and you want to calculate the calculate how much percentage is required. So whatever is given here, yeah, somebody wants to talk? Doubt? Hello? So see, stronger percentage you have to write down first, write stronger, then towards the right side, write weaker, then put arrow marks. And write required percentage is, if you want how much of, I'll use the, Dinesh has already left. Yeah. So if you want to know how much is required, you have to of water is required. For example, in this case, so if it was an alcohol, another strength, if it was the 0 instead of water, some other is there for weaker strength. So how would you take that? So here you would write, this side you would write 95 cross. You have to calculate 95 minus 70 is equal to 25. Will in fact give the weaker strengths part. Okay, and here 70 minus 0 will give the stronger strength part. So how many parts of stronger strength or 95% alcohol is there? It is 70 parts. And how many parts of 0 or this water is there? It's 25 parts. So first you have to write how much volume is required. Then whatever is the required percentage you have to write, that is 70, and how much of alcohol is used. Okay, I think I have to cut short my, it's 1 minute is there, right? 95 minus, yeah, 95 minus 70 is equal to 25. Is it clear, this one, this example? Does anybody
Yes,
have a
ma'am.
doubt? Okay, so
Yes,
whatever we
ma'am.
got was, yeah, okay. So what we had got was only in parts. If you want in terms of volume, you have to multiply 600 ml into the parts what we got from the previous calculation, that is 70 parts, and divided by the strength of that strong one, that is 95% alcohol. And in case of water, you have to do 600 into 25 parts by 95, or as I said, simply you can minus whatever you got from 600. Okay, clear? So I think we can wind up, and I can see people also leaving in between. Dinesh and Pooja have already left.